Okay, for the nomenclature part of this video, we're going to be talking about all ways to name your carbon chain. First, we're going to start out with the root of the name, which is the number of carbons within the parent chain, which is the longest part, or the most number of carbons within the chain. And it goes meth, s, eth, prop, but, pent, and then off of 5, it goes as the normal prefixes go, all the way up to deca, which is 10. And so then we go on to the suffix, which is the number of bonds within the parent chain or within the carbon chain altogether. And that is alkanes, alkenes, and alkynes. Alkanes are the single bonds, and their formula is CnH2n plus 2. And then the alkenes are the double bonds, which is CnH2n, and then the triple bonds is the CnH2n minus 2. And it's important to remember when you're naming these that you put a number within the name designating the location of these double or triple bonds. Then moving on to the functional groups, and that's either a prefix or a suffix. It depends on the functional group. So first we have our halogens, which are iodine, fluorine, chlorine, and bromine, and they have the prefixes of chloro, fluoro, bromo, and iodo. And it's important to remember that that if you have more than one of a halogen, say you have 2 iodines, you have to use a prefix before that saying you have 2. So you would say diiodo for that example. And so and it's also important to remember that these are ordered in alphabetical order. So if you have more than one halogen within a carbon chain, it's important to remember that you'll order it in alphabetical order. And then another important part of this is the cyclo, which means that it's a ring of carbon and it's connected. This affects the number of hydrogens since it's all connected. And so an example of this would be cyclobutane. Okay, moving on to amide. Amide has this chemical formula right here. It's basically a double bonded O and then an ammonium piece right here, and it has the suffix of amide. And so an example of that would be ethanamide. And then amine. And so an amine is the same, but it doesn't have that double bonded O, so it has the ammonium pieces too. And so the primary amine has NH2 on it, the secondary has NH, and then the tertiary has just N. And this depends on the number of bonds connecting it with the carbon on the chain. And so the primary has a single bond, the secondary has a double bond, and then the tertiary has a triple bond. And this one has a prefix and a suffix. So the suffix is amine, and the prefix is amino. And so an example of this is amino ethane. Moving on to an ether. Ether is an O that's separating 2 carbon chains. And so the name for this is alkyl oxy parent chain. So that's just the general formula, but an oxy is the important part right there. And so you'll use the alkyl part as the lower or the fewer number of carbons, and the parent chain will be the larger number of carbons within it, and you'll have the oxy in between it. So it's like a compound word. An example of this is methyl oxyethane. And then esters, they have it's the same thing as an ether basically, but it has another double bonded O on it, or a double bonded oxygen on it, and it has the suffix of oenate. And so an example of this is ethanoenate. And then we have the carboxylic acid, and this is on a terminal carbon. It has an alcohol and then a double bonded O as well, and the suffix for it is oic acid. So an example of that would be ethanoic acid. And that's important to remember that it's on a terminal carbon. And then we have ketone, which is on a middle carbon, and it just has the double bonded O, and the suffix is -one, and this is ethanone. And then we have nitriles, and a nitrile has the triple bonded nitrogen at the end on a terminal carbon, and it has the prefix of CNO, and so an example of that is cyanoethane. And then we have aldehyde, and aldehyde is on a terminal carbon when it has that double bonded O and then a hydrogen. And then we have the suffix of -al, and then you can also use the prefix of -oxy. So an example of this is ethanol or oxyethane. And then we have alcohols, and so we have a primary, secondary, and tertiary alcohol. It all depends. It doesn't really change the naming of it, but it changes the reaction that it goes through. So we all know that this is just an OH, but it's important to remember to draw the bond on the O instead of the H, because the carbon is bonding with the O. And the suffix is -al, and so an example of that is ethanol.
Yeah, those are good.
Or ethanol. Yeah, and then it's important to talk about the saturation of the carbons. More hydrogen on a carbon or an organic compound means that it will be more saturated. So single bonds, because they have those extra hydrogens and they're not taken up by other bonds, that means that they're more saturated, while double bonds and triple bonds are unsaturated because those hydrogen ions, those positive protons, are being taken up by the bonds between carbons or between other things. And then an important term to know is hydrocarbon. A hydrocarbon is basically just compounds that only contain carbon and hydrogen. So it's basically your alkanes, your alkenes, with nothing extra added. So saying methane, which is just one CH4, that means that has no other elements to it, which means it's a hydrocarbon because it is just carbon and hydrogen, and it's the main component within natural gas and petroleum. And so now on to the practice problems.